All right, section 5.2. I'm gone today, so instead of having Mr. Simon go through the notes, this might be the best way to go ahead and do it. So 5.2, we're going to connect the periodic table together with electron configuration as we've been talking about. So remember, we've broken everything down already. We've talked about this before, where this is our S block in black, in green here. This is our D block, and in pink, this is our P block, and then way down underneath here is our F block. So we've talked about that. Now, each group on the periodic table has varying characteristics for each period and each group. So we're going to talk about each group and the characteristics that each group has, and then we're going to break each group into particular characteristics and columns and categories and the names that they have. So if we look at, there are 7 periods on the periodic table. If we go down a group or a family, what we will find out is that they each have the same amount of dots, and we've talked about this: 1 dot, 2 dots, 3 dots, all the way down. And the reason that is if we take chlorine and fluorine, for example, fluorine's configuration is 2s2, 2p5. It ends in 2s2, 2p5, so it has 7 dots. Chlorine's configuration is 3s2, 3p5, so it has 7 dots. If we go down to bromine, bromine is going to be 4s2, 3d10, 4p5. Again, you circle the highest energy group, and it's 4s2 and 4p5. You have 7 dots. So that's kind of how it works for each one. If we focus on the S block, our first block on the periodic table, because we have S, P, D, and F. If we focus on the S block, we're going to take hydrogen from the other side of the periodic table. We're going to throw it in here. And hydrogen and helium are in the S block. However, hydrogen and helium are the exceptions to these rules. So if we look at the very first group on the periodic table, the very first group on the periodic table is called the alkali metals. They are incredibly reactive. In fact, they are so reactive that you will not find any of these elements in nature solely by themselves. They will exist as compounds. For example, salt, sodium, does not exist in nature by itself. It exists as salt. It does not exist as sodium, but it exists as salt, NaCl. It's attached to something. But they're so reactive that they do not exist by themselves. They're so soft, even though they're metals, the group 1, they're so soft you can cut them with a knife, which is unbelievable. And when I come back tomorrow, we'll do a demonstration showing you how you can do that. And as I talked about, they're so reactive, they do not stay in their elemental state very long. They will react with air, they'll react with water, they'll do it all very, very quickly. So something to keep in mind with group 1. So group 1 is the alkali metals. Group 2 is the alkaline earth metals. And what distinguishes group 1 from group 2 is that this group of metals, group 2 here in the blue, you can find them naturally existing in nature. So that's the distinguishing characteristic, the difference between alkali metals and alkaline earth metals. You can find alkali earth metals group 2 in nature. A couple things about group 2 metals: they are harder and stronger than group 1, and they're less reactive. So for example, calcium. Calcium is what makes up your bones. You can find calcium in nature, naturally existing. Calcium is a very hard metal in comparison to group 1 metals. So in the S block, we have group 1, which is the alkali metals. We have group 2, which is the alkaline earth metals. Next up, remember I said hydrogen and helium are the exceptions to the rule. So hydrogen and helium are the exceptions to the rule. Hydrogen is a special S1 element. Its properties are unique. The reason its properties are unique is because it only has 1 neutron. It has one proton. It has 1 proton. It has no neutrons. It has 1 proton and 1 electron. Hydrogen's unique. It's not like the group 1 elements, but it's placed there because it has that S1 configuration. So hydrogen is there because it does have 1 electron in its outer shell, and it reacts very similarly to the rest of them that have 1 electron in their outer shell. Hydrogen is flammable. Right? It is a odorless gas, and it exists all the time. It's in the air in small amounts. Helium is a special S2 element. It's placed all the way over with the noble gases. Why? Because its outer level is full. 1s2. Helium and hydrogen are the only 2 atoms on the periodic table in which their outer shell will not have 8 electrons. Hydrogen and helium's outer shell only consists of 2 electrons. So something to keep in mind there when we talk about why hydrogen and helium are the exceptions. Helium is very stable, just like a noble gas. That's why it's in the noble gas category in group 18, and it does not react with anything. So hydrogen and helium are very unique because they only have 2 elements in their outer shell, and 2 is all they need to have a complete full outer shell, unlike the rest of the elements who need to have 8. Talking about P block, we'll move over to the P block. There are 3 categories that I really want you to focus on in the P block. First off, we have talked about the metalloids. You naturally have a border right down the middle here, all right, which highlights all of these, right, all of these light blue elements. These are all metalloids. Those are all metalloids. The reason, let's review again, the reason they're metalloids is because they have characteristics of metals and nonmetals. Now, what are characteristics of metals again? They're great conductors of heat and electricity. They're solids at room temperature. They're ductile and they're malleable. Ductile means they can just be pulled into wire. Malleable means they're bendable. So things that we've reviewed about metals before. And then nonmetals have those opposite properties. So that's metalloids. The second to last group on the periodic table is group 17. I'm going to highlight that in pink here. These are called the halogens. The halogens are the most reactive nonmetals. And why is that? Well, look at it. Look at it overall. They have 7 electrons in their outer shell. Remember, every atom wants to have 8. So they are 1 electron short from having a full outer shell. So they will do pretty much anything to get 1 electron from other atoms. That's why they're very reactive. They're most reactive nonmetals. You go through that list, you know a handful. You know fluorine. What's fluorine used for? It's used in toothpaste and for whitening of teeth. Chlorine, what's chlorine used for? You're probably thinking pools. All right, bromine is a toxic red gas. All right, that's kind of a neat little fact about bromine. Bromine actually exists as one of the 2 elements that exists as a liquid at room temperature. And then iodine. Iodine is used to sanitize and sterilize wounds and when doing surgeries and stuff. So you're very common with the halogens. So that's the second to last group on the periodic table. Last group on the periodic table, which is highlighted in yellow there, is our noble gases, and we've spent plenty of time talking about the noble gases already. The noble gases have a full outer shell of 8 electrons. Therefore, they are stuck up, and they do not react with hardly anybody. So, neon, argon, krypton, xenon, and radon are all noble gases. They're not very reactive because they have 8 electrons in their outer shell. These gases do serve purposes in the real world. However, they are not very reactive. So that is the P block. If we move to the D block, the entire D block is labeled as one thing. It's called the transition metals. Really, it's called the transition metals because we're moving from one side of the table to the other. So the transition metals are moving from one side of the table to the other. Just like metals, they carry all the properties of metals. They are excellent conductors of heat and light. They are shiny. They are malleable. They are ductile. These are all the metals, transition metals. Now, some of them have varying properties that we'll talk about a little bit later. Anyone want to guess out of the transition metals which one's the most expensive? Now, you would think gold. Gold's trading at about $1,300 an ounce. It's actually going to be palladium. Palladium trades at about $3,200 an ounce. And tomorrow, remind me tomorrow, I'll pull up the list and we'll show exactly how much the price of each of these metals are in the D block. So you know some of these actually. You know what iron does. Iron's used to make steel and other things, building structures. Copper is used in wiring and piping, and it's pretty expensive right now. Titanium is what makes golf clubs. It's a very lightweight, very durable metal, so it's used to make like what's the word I'm looking for? The hull of airplanes, because it's very lightweight, but it's very durable. It's also used in golf clubs. If you like broke your leg and need to get a rod in your leg, most likely it'd be made of titanium. So very useful, very purposeful part of the periodic table, the transition metals. So we have the S block, the P block, the D block. If we go to the F block, all right, the F block is broken down into really two categories. We have the lanthanides, which are the first group, and we have the actinides, which are the second group. These fill the energy, and these are really referred to as the rare earth metals. And we will talk about the prices of these. In fact, if you do your element project, if you have one of these, it's actually a pretty cool element to do. A lot of the electronics that you have, your iPads, iPods, iPhones, Androids, tablets, Kindles, all that stuff, typically require some type of these rare earth metals. Like the Toyota Prius is very heavy in these rare earth metals. Because they are very valuable. They have very good characteristics. A lot of the backlighting in your electronic devices is not made possible without these rare earth metals. So they do serve a purpose. However, they are not very environmentally friendly to mine, which creates problems in environmental hazards getting them out of the ground. So there are difficulties with that. But those are the rare earth metals. So if we had to break it up, the S block has two groups: alkali metals, group 1, and the alkaline earth metals, group 2. The P block, we break it down into really... I want to talk about this P block actually too. One thing I forgot to mention as I'm summarizing. The teal here is the metalloids. The highlighted in pink was the halogens. In the yellow was noble gases. The remaining red elements we just referred to as nonmetals. Group 16, 15, 14, and 13 don't really get grouped together. So the remaining in red, which would be these, the remaining in red, just get referred to as the nonmetals, just to clarify. So the P block has the metalloids, the halogens, the noble gases, and the rest, the leftovers, is nonmetals. The D block is the transition metals, and then what we just got done talking about is the F block is the lanthanides and actinides, which are both rare earth metals. So that kind of concludes 5.2. If you have any questions on the lesson, make sure you write them down, and we will get them answered when I come back tomorrow.